Welcome to The Explainer. Today, we're diving into the journey of data through a modern pipeline built right on the Databricks platform. We're going to explore this really powerful shift away from the old way of doing things, ETL, to a much more flexible approach called ELT. That's where we load the data first and then transform it later. Let's get into it. All right, here's the game plan. We're going to start with the foundation of this whole thing, the Lakehouse. Then we'll follow the data as it gets pulled in and then shaped up using SQL and Python. We'll even look at the Photon engine, which is like a turbocharger for the whole process. And finally, we'll wrap up with how everything is managed, governed, and kept running smoothly by Delta Lake.
So, to really get a handle on modern ELT on Databricks, we've got to start with its architectural heart, the Lakehouse. This whole concept was born to solve a really old problem in the data world, this annoying split between super flexible data lakes and these rigid, structured data warehouses.
The core idea here is actually pretty simple, but it's a huge deal. It's all about getting rid of data silos. So instead of having one system for your messy, unstructured data and a completely separate one for your clean, structured data, the Lakehouse gives you a single platform for everything. That means you can do all your work, from engineering to BI, on just one copy of your data. And that means faster insights and, lower cost.
For the longest time, you had to make this tough choice, right? You could either have the wild, raw flexibility of a data lake, which is great for things like machine learning, or you could have the reliable, structured performance of a data warehouse for your business reports. The whole point of the Lakehouse is to just get rid of that choice. It's designed to give you the best of both worlds, all in one place.
Okay, so we've got our Lakehouse foundation ready to go. How do we actually get data into it? Well, that brings us to the very first step in our data's journey, ingestion. In the ELT model, the name of the game is speed. The goal is to get that raw data onto the platform as fast as humanly possible, way before any heavy lifting or transformations happen.
And Databricks gives you this whole versatile toolkit just for ingestion. Autoloader, that's your go-to for efficiently loading streams of files from cloud storage. Then you have Lakefloat Connect, which has these handy pre-built connectors for big enterprise apps like Salesforce. For just a straightforward batch load, you can use the copy into command. And of course, for real-time data, structured streaming is there to handle things like event streams.
So where does all this data go once it's ingested? It lands in what's called the bronze layer of the medallion architecture. The best way to think about this is like a digital loading dock. It's the landing zone for all your raw, unfiltered, untouched data. By capturing everything in its original state first, you create this perfect, durable source of truth before you start changing anything.
All right, our raw data is sitting safely in the bronze layer. Now comes the T in ELT, transformation. This is where the magic really happens. We start to clean, combine, and shape that data, moving it up through the silver and gold layers to get it ready for some serious analytics and AI.
And you've basically got two main ways to get this done. On one hand, you've got the SQL highway. This is perfect for analysts and engineers who are already comfortable with standard SQL, and it makes it way easier to move over from older systems like Redshift or Snowflake. Then, on the other hand, you've got the Python workshop using PySpark. This gives you all the power and control you need for really complex logic or integrating machine learning.
And here's the really cool part. It doesn't matter if you're cruising down the SQL highway or tinkering in the Python workshop. There's this incredibly powerful engine working under the hood to speed everything up. Seriously, think of it like a turbocharger for your data pipelines.
That engine is called Photon. And yeah, you're seeing that number right. It can deliver some serious performance gains. We're talking up to 12 times faster for certain SQL and data frame jobs. And that kind of speed doesn't just mean your jobs finish faster. It actually lowers your compute costs.
So how in the world does it work? Well, instead of processing data one tiny row at a time like older engines, Photon uses a technique called vectorization. Imagine it grabbing an entire column of data at once in these big batches. It just makes way more efficient use of modern computer hardware. It's a total redesign for pure performance.
Now, here's the crucial thing to remember. While Photon is unbelievably fast for all the standard stuff like joins and filters, it does have its limits. It doesn't speed up custom code that you might write in Python or Scala. That kind of code is usually wrapped in something called a user-defined function, or UDF. If your query uses one of those, that part of the job just runs on the standard Spark engine, no boost.
Okay, having a super fast engine is awesome. But when you have a complex data journey happening across all these different layers, you really need two things. You need a map to guide the way, and you need a set of rules to keep everything organized and secure. And that's exactly where orchestration and governance come into play.
This is your map. Instead of writing tons of complex code that says, do this, then do that, you simply declare what you want the final data to look like. It's a tool called Lakeflow, which used to be known as Delta Live Tables, and it takes care of all the rest. It manages all the dependencies, scales the infrastructure up and down, and even handles data quality checks for you. It's a game changer.
And this is your rule book. Unity Catalog is like the central librarian and the security guard for your entire lakehouse, all rolled into one. It handles who gets to see what data, it automatically tracks the lineage so you can see exactly how data is flowing from the source to a report, and it makes all your data easy to find in one central place. All right, let's peel back one final layer and look at the foundational technology that makes all of this powerful orchestration and governance even possible. See, underneath everything we've talked about is a very specific storage format, Delta Lake. Every single table on the Databricks platform is built using this open-source Delta Lake format. Now, this isn't just some small detail. It's huge because it brings critical database-style features directly to your files in the data lake. We're talking about things like ACID transactions for reliability, versioning that lets you time travel to see what your data looked like yesterday, and schema enforcement to stop bad data from corrupting your tables. But Delta Lake isn't just about being reliable. It's also incredibly smart about performance. It has these intelligent optimizations that are always working behind the scenes. Liquid clustering, for example, automatically adjusts how your data is physically laid out to make queries faster, which is way more flexible than old-school partitioning. And then there's predictive optimization, which uses AI to automatically run maintenance tasks to keep your tables in tip-top shape.
So what's the real takeaway here? Well, by bringing together ingestion, transformation, governance, and a high-performance engine all on a single open foundation, you get this incredibly smooth, seamless path. It's a path that takes you all the way from messy, raw data to advanced analytics and even massive enterprise-scale AI, without all the friction of shuffling data between a bunch of different systems.
This kind of deep integration just shatters the old silos that used to exist between data engineers, data scientists, and business analysts. It lets everyone collaborate on a single source of truth. And that leaves us with a final, really important question to think about. When your data, your analytics, and your AI all live and work together on one platform, what becomes possible?